My name is Dan Shumsky. The title of my poster is Calibration of the LANP Model Using George Miley's Published Data. The poster presents the least action nuclear process theory of cold fusion. This is a theory that's based entirely in classical physics. All of its fusion reactions and all of the decay of unstable fusion products rely entirely on well-established principles of nuclear chemistry. It's the way that nuclear processes work. Why should anyone think that anything different is going on in our experiments? The poster presents the model calibration against the single most complete set of transmutation data available, that published by George Miley for his electrolysis of thin film nickel electrodes in water. I'm going to begin toward the end of the poster. I want you to see where we are going, and then we'll come back and see how LANP theory got us there. This is the model calibration output. It's a list of all possible nuclear reactions given Miley's initial electrode composition. It contains nickel's 5 isotopes and 7 isotope impurities, including those of vanadium, chromium, iron, copper, zinc, and silver. Allowing 1 to 4 protons to participate in the transmutation process, there are 1,262 possible initial transmutations. The model calculates the fusion energy requirements for all 1,262, and then it displays them in the order of increasing fusion ignition requirements. LANP theory says that the internal energy in the operating electrode increases continually during electrolysis, and transmutations occur in the order of increasing fusion ignition requirement. That's the order that you see in this table. I'm going to focus your attention on the 4th transmutation in this ignition sequence. It occurs at 0.12 MeV. A chromium 50 nuclei fuses with a zinc 70 nuclei and 4 neutrons to form xenon 124. Xenon 124 is known to be capable of decay to tellurium 124, which in turn is capable of spontaneous fission to nickel 61 and nickel 62. However, even though they are thermodynamically possible, these decays do not occur in nature, but they do occur in LANP theory. The next part of the table provides the energy components of the overall reaction in atomic mass units. I want you to see that the fusion ignition step can be positive or negative, that is, it consumes or liberates energy. However, the fusion product is, if it's unstable, it decays and it always results in excess heat. In this case, 0.035 atomic mass units or 33 MeV. The excess heat calculated by the LANP model is generally in the 2 to 4 watt range, which is exactly what Miley reports. Here's a plot showing the model's percent match to Miley's observations. The agreement is almost 100%. The poster describes how even the outliers can be explained. The agreement between the model calculations and Miley's observations is this good because the underlying process is absolutely deterministic. Now let's go back to the beginning of the poster where I can tell you more about LANP theory. I'll begin by making a distinction between theory and model. A theory is a collection of ideas and equations that explain a physical system. A model, on the other hand, takes the theory and represents it in a form that can be used to predict outcome. Models include numeric values for all of the unknowns in the theoretical framework and flesh out precisely how the theory's elements become part of the calculation procedure when it predicts outcome. The model calibration, if done properly, can provide numeric scores for how well the model fits experimental measurements. The LANP theory is now set up as a computerized model that predicts new isotopes and their order of appearance. It does so with almost 100% accuracy. Let me tell you a little bit about LANP theory. The process has 2 steps. The first is a fusion step. It occurs when the ignition energy for the first fusion reaction is reached. It can consume or produce heat. The second step is the decay of unstable fusion products and to their final stable isotopes. This is the primary source of excess heat. Understand that the first element of any cold fusion theory has to be the source of the thermonuclear energy that drives the process. Here, the source of the energy is the kinetic energy of protons and deuterons. Read the poster to understand how this happens. You're aware of the continually increase in internal electrode energy. Let me tell you something about its consequence. Here I show the emission and absorption of a shared gamma-level electromagnetic wave between two nuclei. As the electrode's internal energy increases, this gamma energy increases, the wavelength decreases, and the process results in ignition. I want you to recall how xenon-124 decayed to tellurium-124 and then underwent spontaneous fusion to nickel fission to nickel-61 and nickel-62. Here are the calculations for the spontaneous fission reaction. The 4 thermodynamically possible spontaneous fission reactions are shown here. You should verify the calculations on your own. But I want to focus your attention on the LANP selection criteria that tells us which of the 4 reactions occurs. It is the principle of least action, and it requires that the reaction that occurs next is the one that results in the smallest energy change. The model also permits a comparison of isotope production rates determined by Miley with those calculated by the LANP model. Let me explain to you the theoretical process that causes the distinct production peaks in Miley's curves. It's fusion and fission reactions. Let me explain. Do you see how the isotopes in Miley's electrodes are in 2 mass number groups, 60 and 108? Let's look at those in the 60 class. Do you see how fusion of isotopes in this group undergo fusion to form isotopes having approximately 120 atomic mass units of weight? And those in turn fuse to create 240 weight isotopes. The same happens as the 60 weight isotopes undergo spontaneous fission to 30 weight and 15 weight. Miley estimates that about 66% of newly formed isotopes are those already in his electrode. I call this recycle. The LANP model shows a comparable level of recycle. You can access my book for free at Leonard Forum's Goodreads, or you can purchase it at Amazon.com. Those of you in Poland can also get a copy of the LANP computer model. Thank you.